Okay, example 3. In the beginning, there were 4.25 ounces of radioactive material. It decayed exponentially. So again, I see the word exponentially, I immediately go to my structure, which is the final amount is equal to the initial amount, e to the kt power. Again, as soon as I see exponentially, that's the structure every single time. And the three things I care about is how much do we start off with, how much do we end up with, how long did it take. So, we started off in the beginning 4.25 ounces. In the end, we had 3.92 ounces. And it only took 10 years for that to happen. This is a pretty stable radioactive material here. There's more unstable stuff. The half-life is like, I think, polonium-212 or something like that. It's 1/10,000th of a second is the half-life. So, if you had like a mountain-sized thing of polonium-212, in about 8 seconds it'd be gone. It's just crazy fast half. I don't even know how they know it exists. Yeah. But they say it does, I'll believe them. Anyway, I might have the number wrong, polonium something, but somewhere in the 200s. Yeah. But anyway, this is not decaying very rapidly, but it is decaying. Radioactive material in general, if you set it down, it decays, it just disappears. It kind of reminds me of evaporation, but it's not exactly that thing going on. But once again, it's the same setup as before. We know how much we ended up with, how much we started with, and how long it took. So if I put these numbers in, 4.25 equals 3. No, that's not right. 3.92, the final amount, equals 4.25, the initial amount, e to the 10k power. Decimal point more noticeable. Once again, I've got a number in front of e to the power, so I want to divide by that number, even if it doesn't divide pretty. So 3.92 divided by 4.25 comes out to 0.9224. Equals e to the 10k power. Once again, I want 0.9224 to be written as e to a power. So I'm going to say e to the x equals 0.9224, which means that ln of 0.9224 is equal to x. So natural log of 0.9224 is what I need to do. That comes out to negative 0.0808. Is equal to, e to that power. E to the negative 0.0808 equals e to the 10k, which leads me, obviously, once e to the power equals e to the power, that the power on the left is equal to the power on the right. Divide both sides by 10. We get k equals 0.0081, negative 0.0081. All right? So we know the value of k to 4 decimal places. So once again, if I look at this original statement structure that I've created, a sub 0, the initial amount, will always be what it is. And the k is the constant, which will always be what it is once we know what it is. So once we know both of those numbers, we can rewrite the formula as the final amount of material equals the initial amount, which is 4.25, e to the k, which is negative 0.0081 times t. And once I get to that point, how much remains after 30 years? So again, they'll either ask me this or this. 30 years is the time, the correct unit of time, right? 30 years. So I just changed the t to a 30. The amount after 30 years should equal 4.25 e to the negative 0.0081. Don't change your numbers. That causes wrong answer. 0.0081 times 30. So I type that in my calculator. 4.25 times second ln. I'm trying to do e to a power, so I want e to the power to show up. The power is negative 0.0081 times 30. Make sure both numbers get within the parentheses. It equals, and we get 3.33 ounces.